Hi, a good day, good afternoon, good evening, ladies and gentlemen, comrades and friends. My name is Mr. Mbari John from the Ministry of ICT, Post and Courier Services. Will you allow me an opportunity to present my attempted assignment in the following tools? So I'm going to be using number one, PowerPoint presentation, which I'm actually looking at right now. Number two, Jupyter Notebook using Iris dataset. Number three, natural language processing techniques in Python. Number four, evaluation matrix screenshots. So maybe if you can allow me to run it in a magnified way. So in terms of my understanding of the building methods, techniques in machine learning from what I've covered so far, number one, called all-in. In terms of description, it is usage of every feature or column available in your dataset without leaving any one. For example, size, bedrooms, bathrooms, location, color, nearby schools, crime rate. If it were maybe choosing an area of residence for a tenant, you'd have all those factors in consideration, maybe affecting even the rates, rental charges. It is analogous to invite everyone in your contact list to a party without any filtrations, everyone included. Number two, forward selection. This one begins with no features or with at least a best predictor. Then you continue to add the next most useful feature one at a time until there's no meaningful improvement to the model. Analogous to building a team by hiring the best candidate and first, and then you add another next best, and then until you find that the expansion issues are going to creep in, and then it affects your what quality of your model. Number three, it begins backward elimination. It begins with all in baseline factors. Then you start removing the least significant features. For example, color, field, and paint. If it is for a house, remove and then you stop when you think that the degradation of the model accuracy. Number four, bi-directional or also called the stepwise selection. This is a cross of the forward and the backward. In other words, it allows you to add and to remove some time. So it is the base of both worlds, which runs dynamically on the run for the best destination point. It's analogous to hiring a manager who not only hires a new team member but also reviews and fires underperformance at every run. Then number five is a score comparison technique, which is a basket approach where in three or more approaches are tried in the model with the best accuracy of the predictions is adopted. But clearly, this is much more complex in terms of analysis, although may be quite useful in terms of quality. So among those key comparisons options, number five one is multiple methods comparison, which can cover all features, forward selection, backward elimination, bi-directional elimination, PCA, principal component analysis, random forest feature importance, F1 score, and cross-validation scores to cover the mean average and standard deviation. Then number two, it could be multiple matrix. A number of matrices involved accuracy, precision, recall, F1 score, and cross-validation scores as well, covering mean and standard, even like the previous multiple methods. It can also be in terms of visualizations, which could be in form of bar charts, graphic charts, F1 score charts, cross-validation scores, feature and accuracy scatter plots, and feature count comparisons. It could also be an automated base model selection, which identifies the models by different metrics, and then you save the files, the CSVs for further analysis. So the next field slide, and the last, I think, the extracts, screenshots from the live run from the Jupyter course that I had to shadow box and see what was coming up in terms of the results. So allow me to exit temporarily from this PowerPoint and maybe go to to the Anaconda Jupyter notebook. So what I did, I created a folder in my home directory called desktop JMC. JMC is for Johnny Berry, something else, John Berry Scala, something that's my names. Then I go to inside of those home options. I do have those one, two, three tabs. So I'm just going to close them so that I can try one by one to see what's going to coming up. So I'm beginning with all in one, which contains a section about three sections. One to do with importation of libraries. If we're going to run it, successfully compiled, go to the loading of data, running, successfully compiled. Then I go to the main logic. Let's see what's gonna come up there when you take all the features. Ah, beautiful. We also see compilation of all the items. The first part there talks of the first five records indicating what is contained in that particular data set. Then the samples are 80%, 120 to 30, total is 150. Then this metric is 90% for the accuracy, which is very, very significant. So we need to keep on keeping in mind and see how it compares with the other options if you to choose the models. So if I go back to my home tab, I pick the second, I prefer forward selection. I also have the same libraries because I'm using the same data set. And then I go to my loading data set, get into a data frame. Then I go to the main logic and see what's gonna come out from there. So I see some graphs and then I go to the evaluation model. It's about 76%. The previous one, all in was 90%. So these are the changes, the variations that we see, and you need to diarize and keep them maybe in an array of results. Then you see we're able to do an aggregation of the summarized analysis, maybe in the last option. Then you go back to the home tab, so go to the bi-directional, the one that picks most of the what was the addition and subtraction. We run again just to clear the buffer. We run again, importation of the data, we see something, then we go to the main logic. I'm running again, see what do we see here when it comes to the bi-directional. I see resounds, thermal moderates, but I also see that it has got 76.67, almost the same, actually it's exactly the same thing with the previous one. So you may find that if you were to choose between bi-directional and forward selection, the accuracy is the same. But then in terms of maybe code consumption, resources of server processors consumption, you may find that there's no need for adopting bi-directional. It's complicated for no reason when they're having same metric accuracy with the forward. Rather keep the forward with the lesser coding, I think. And then we go back to the last one to do the score comparisons. Go the same process quickly, run the libraries, the data frames, and then go to the main logic. Now, these are the tools that you have to fully understand, I think. So there is a summary of those results. I'm trying to go through so that I don't drop some information there. I see number one, all features baseline. Even if one score one's the one, then equal 0.65 for one score, then percentage 83%. Then I go to bi-directional or I put into one. Then you can make a juxtapose comparison of those options and maybe adopt the best one. So I think these are the last part is what I had to snapshot and check it to PowerPoint. So I'm going back. Allow me to go back to the last two slides of my PowerPoint because and allow me maybe to just zoom them in a magnified manner because I'm just magnified them in the current. So this is an aggregation of the all features. Let me take a highlighter. I just want to highlight something there. Let me the highlighter. This is what all these all features. This is what this is 90%. Forward selection. This is what this is 76%. This is what this is also 76.67%. So these are the comparisons that we are now having. Then the last part is continuation again. Because I see the section one here, then the section two, so it means it's the first part and second part. Otherwise, continuation of the analysis. So this is so I think, ladies and gentlemen, you may allow me actually to call it a day at this point, and thank you very, very much.